and other cannot. Okay, I get what you need. I see. But let me know what's your plan for the final exam. The material for the final exam would be much more than your midterm. What are you doing for your final exam? It would be harder for you. Yes, I see. I know. Same here. I know it's Ramadan. And many other problems. But this is a master course. It is essential to learn a lot of materials, you know? Okay, I know what's the problem, I see, and I had the same problem. We will discuss it later. I will see if I can reduce the material. Okay? Okay. I will verify your demand, and if it is possible, I will do. But you need to work much harder, you know? Yes, I will send the solution as well. I will send you the solution. Okay. We don't have so much time. We continue some materials of the last session. Okay, let me start. The presentation. Yes, I will record like always. I will. In the last lecture, we started speaking about data encryption, and we explained some taxonomies in this area, and we will continue some remain topics just in 20 minutes maybe. We had some taxonomies in data encryption, some basic terminologies, as you know. We said plain text is the original message, ciphertext is the coded message, and we have encrypt and decrypt, which they convert and recover the plain text to ciphertext and vice versa. We said that for any encryption algorithm, we have a secret key which needs to be unknown to untrusted third party. Just the key must be known and available for the sender and receiver. And we say that cryptanalysis is the study of methods, algorithms, and principles of deciphering ciphertext without knowing keys. Which means that when an attacker who has access to ciphertext, how he can break the cryptography schemes. There were the main terminologies that we explained in our previous lecture. Anyway, it is important to know when a cipher is known to be secure. There are several parameters that need to be verified to determine if a cipher is secure or not. The first one is the hardness of recovering the key. If the attacker has access to some ciphertext, if it is possible to learn the key, how much resources, how much times, or how much, for example, CPUs and memories he needs to recover the secret key. The other parameter is how he can recover plain text from ciphertext without accessing to the secret key, without knowing the secret key. If it is possible, if attacker can learn some bits, not completely the plain text, some bits of plain text, or some functions, or some information from the plain text, your cipher is not secure. Another parameter is mapping from plain text to ciphertext. What does it mean? It means that imagine you have some ciphertext here, for instance C1, C2, something like that, and C3, for instance. What is my C2? Okay, and in the other part They are the encryption related to some message, for instance M2, M1, and also M3. It is so important to know that if the attacker is able to map between each ciphertext to the identical plaintext. For instance, he can say this ciphertext is related to M1, this one is related to M2, and this one is related to M3. Mapping from ciphertext to plaintext or vice versa. If he can do some such kind of mapping, your cipher cannot be secure. Okay? It is not secure, your method. Let me have some real example. For instance, you have some messages, some numbers. For instance, 12. The other number is 45. The other one is again 12. And we also have, for instance, let me say, I don't know, 18. And in the other side, you have the encryption of each item. For instance, the encryption of 18 is something like this. For instance, 04x. Then you have the encryption of 12, something like this. Again, the encryption of 35, for instance, is equal to this one. And the encryption of this 12 again is 5, 6. As you can see here, we have the same ciphertext for this plaintext. The first 12 is mapped to this ciphertext, and the second one is the same. You see? They are the same. This is the message here and here, which are equal, and in the other part you have the corresponding ciphertext, which are the same. Interesting. In this encryption method, when the attacker has access to this part, to this ciphertext here, he can see only, he can see this part. He cannot learn the secret key, but he can say that there are two equal numbers in plaintext, in the corresponding plaintext. He can learn this information. Okay, here you have some numbers, 18, 12, 35, again 12. Okay, for instance, they are your grades, your midterm grades, your midterm marks. We encrypt your midterm grades here, each one. You can see here the first one, 2, 3, 4. You can see the encryption of this part 12 12s are equal. We have we have I'm trying to use my pointer as well. You have the equal ciphertext for the same plain text. For the same plain text here, M2 and also M4, this is M2. We have equal ciphertext. C2 and C4 are the same, are equal. You see here. When the attacker is seeing this ciphertext, he cannot learn your secret key. But the attacker can learn that there are two equal ciphertexts. In this situation, you cannot say that your cipher is secure. No, it is not secure. We say that your ciphertext leak some information. There are some leakages, which means that some information are appear in your ciphertext. Okay. This is so important to know this terminology. Okay. This slide, I don't know what happened to this slide. There are several ways to break an encryption scheme. First one is known as ciphertext only attack. What does it mean? It means that the attacker, for example, 3D, the attacker, has access to ciphertext. She can analyze the ciphertext. This is known as ciphertext only attack. Ciphertext only attack. The other approach is non-plaintext attack. In this attack, the attacker 3D has access to plaintext corresponding to some ciphertexts. We will explain it in the future lecture. There is another kind of attack which called chosen plaintext attack. Chosen plaintext attack, in this way, the attacker can get ciphertext for chosen plaintext, which means that the attacker can encrypt some plaintext. It is so important to know the difference between two methods of attacks. Non-plaintext attack, the attacker has access to some plaintext and their corresponding ciphertext. But in the second one, chosen plaintext attack, the attacker has access to ciphertext for some chosen plaintext. They are not the same. Okay? We have two approaches for finding the secret key of an encryption scheme. The first one is called brute force attack. Brute force attack means that the attacker needs to search through all possible keys. And the other one is statistical analysis. In a statistical analysis attack, The attacker can do some statistical calculation over the ciphertexts. As I explained in the previous slide, for instance, the attacker may find the duplicates in ciphertexts. It could be dangerous, as you know. Okay. Generally, the cryptographic methods can be classified into main two categories: symmetric key encryption or cryptography. In symmetric encryption, two parts, for instance Alice and Bob, use the same key. Here we can see the key are the same in Alice's side and also in Bob's sides. Here the problem is, how do Bob and Alice agree on key values? There are several methods that we can explain some of them. And we also have the encryption algorithm and also decryption algorithm. Using the encryption key, the message plaintext is encrypted into ciphertext. And using the same key, the encrypted message, this one, can be decrypted by the same key, KS. And after decryption, Bob can see the corresponding plaintext, M, the original message. There are another methods which called public key cryptography. In public key methods, we have two encryption keys. Alice and Bob, they have their own keys. Normally, in public key encryption, the plaintext is encrypted using the public key. This public key is available for all people, for all. Which means me, you, we can encrypt any message. There is another key which called private key. The private key is known only to trusted parties, for instance, only for Bob. Using this private key, the encrypted message, the ciphertext, can be decrypted. Here, the public key is shown as K plus, and the private key is shown as K minus. Using K minus key, private key, we can decrypt the ciphertext and get access again to the plaintext. Okay, I guess for today it's enough. Let me know if you have any question. Okay, I will upload the slides and also the recorded lecture like other lectures. I will see for the material of your midterm. We said that the date of your midterm is next week at the same day like today. Yes? Am I right? Okay. Hence, the date and the time of midterm is fixed. Just I need to see if I can reduce the material. I will inform you in WhatsApp group. If you don't have any question, okay. Have a great time and bye for now.